Okay, so graphing logarithmic functions. First, you need to understand that the notation is log base b of x, but if you had ln, that's a natural log, and that just means that your base is e. And if you had a log with no base written, that's a common log, so your base is 10. So the difference between a log where you can change your base, natural log, and common log is that for the natural log, your base is e, and it'll never change. And a common log, your base is 10, and that'll never change either, because by definition it can't. So to make my table, what I'm going to do is rewrite my logarithm as an exponential. So my base to the y equals x, so I just write it, these two things are equivalent. And then instead of using the x values of -2, -1, 0, 1, and 2, logarithms and exponents are inverses, so I just put those values in my y column. And then similar to the y equals b to the x, I just put those values over here in my x column. So now the x and the y values have just interchanged because they are inverses. To see what transformations look like, if you have vertical transformations, you'll see a number outside of the log. That'll be a vertical dilation. And if you have a number before the x inside the parentheses, that will be a horizontal dilation. A negative before the log is a vertical reflection. A negative with the x is a horizontal reflection. A number outside or after log base b of x, that's going to be a vertical translation. You add, you move up, you subtract, you move down. And then log base b with the x plus or minus a number inside of the parentheses is going to be a horizontal translation. This is the opposite. So you add, you move left, you subtract, you move right. Similar to exponentials, you have two different situations where your base 2, or if you have a base 1/2, they're very similar functions. They are just, the log base 1/2 is a reflection of log base 2, and it's a vertical reflection. So if your base is 2, it's equivalent to a negative out front of log base reciprocal of that base, because 2 to the y equals x, so 1/2 to the negative y is also equal to x. Because if you had a negative exponent, and I had a negative exponent down here, I just rewrite it as 2 to the y. One thing to notice regarding the bases, if your base is bigger than 1, that's going to affect the steepness of the graph. So it's going to be less steep from left to right from your key point. And then if your base is between 0 and 1, that's what I'm just talking about here. So the reciprocal bases are a vertical reflection. So I will just show you a quick screenshot here. So on the screen in green, I have log base 2 of x, and in blue I have log base 20 of x. So as you can see, as it goes to the right, it's less steep for the bigger base. And then I will show you from green, we've got log base 2 of x. If I take that off, this is negative log base 1/2 of x. It's literally the same graph. It's just a reflection. So if I take the base of a half and I take the negative reflection off, you can see they still go through 1, 0, and they are reflected over the x-axis. In regards to graphing, I showed you how to make your table by hand. You would pick your base and write it as an exponential and putting your x values there. You used to for exponentials in your y column, and then fill in your x's. So I would do the 0 first. Its output is going to be 1, and then 2 to the first power is 2, 2 to the second power is 4, and then over here with the negatives, they're just reciprocals. So the reciprocal of 2 is 1/2, the reciprocal of 4 is 1/4. So I would first plot my key point, 1, 0, before transformations are always going to be on the graph of logarithms. And logarithms have a vertical asymptote, so I would dash my vertical asymptote in. For the parent functions, that's going to be at x equals 0. The only thing that's going to change your asymptote is a horizontal translation. So if you shift it to the right, then your vertical asymptote will also shift to the right. So here's a graph of log base 2 of x. If I place it on top, if I shift it to the right, you can see your asymptote goes with it. If you instead shift it down, then your asymptote stays exactly where it is, and then you can still follow the same procedures for your reflections and dilations.